When considering the possibility of life beyond Earth, the search focuses on three main ingredients. The first one is key elements such as carbon, hydrogen, oxygen, and sulfur. The second is a source of energy. And the third, and perhaps most important, is the existence of liquid water. Water is a necessary solvent in all chemical reactions that have to do with life. Energy is required to drive these chemical reactions, and organic matter is the material from which all life that is currently known is made. Life as it is currently understood requires liquid water. It is believed that life on Earth started in the oceans, and through exploration of the solar system, it has become clear that the moons around the giant planets have the right conditions, that there could be liquid water underneath their surfaces. And so that really sort of expands the whole concept of where a habitat might exist, where life could potentially be found. Water is fairly common in the universe. Traces of water have been seen in large molecular clouds between stars. Traces have also been seen in protoplanetary disks. Water vapor has been observed in the atmospheres of giant planets around other stars, and water is present in the atmospheres and interiors of the solar system's giant planets. So water is known to be ubiquitous throughout the universe. As for liquid water, that's a little less common. Earth is the only planet in the solar system where liquid water is observed at the surface. Moons such as Enceladus and Europa may have liquid water beneath layers of ice. This is expanding the understanding of what makes a place habitable. Instead of just looking for an Earth-like terrestrial planet that's a very specific distance from its star, it is now understood that there can be hidden habitats underneath icy layers, and they can be much farther out from the Sun. It is now believed that icy moons in the solar system actually harbor kilometers-thick oceans beneath their icy surfaces. These icy moons and their subsurface oceans may be some of the best places to search for life elsewhere in the solar system. Enceladus is one of Saturn's many moons, and it's a very small moon that people tend to kind of ignore. It's so small, about 5 or 10 kilometers in diameter, but decades ago in the 1980s, from ground-based observing, it was found that the location of Enceladus relative to Saturn happened to coincide nicely with Saturn's E-ring. And so there was a suspicion that Enceladus had something to do with the E-ring particulates, the icy material, but it wasn't certain. What was later found from Cassini was that it was directly determined there are indeed plumes jetting out of the South Polar region from cracks in the South Pole of Enceladus in the crust, and it's dominantly water-rich material just jetting out into space. And so, the way it was seen, Cassini happened to be located where Enceladus was backlit from the Sun. And so, this curtain of beautiful, diffuse material was visible, jetting out of the South Polar region. Quite breathtaking, actually. Even more, the different complements of instruments on board Cassini were used to go after the chemical composition of the plumes. And that's where things got really interesting. So, number one, that's because of liquid water. There is definitely a liquid water reservoir. It's subsurface below the icy crust, but that is there. Number two, the chemical composition of the plumes showed that there's a lot of organics, things that make up amino acid, and things on life that are very interesting. And number three, what is really being looked for is a source of energy on Enceladus. Photons from the Sun aren't going to work because they can't penetrate the tens of kilometers of icy crust to get down to where the liquid water reservoir is. But what Enceladus does have is hydrothermal vents. It's very hot, and the liquid water has a lot of analogies with the ocean floor, where there is a form of releasing chemical energy via something called serpentinization. And so it is thought that Enceladus might have that potential to have an energy source being chemical, not sunlight. And so when all that is put together, Enceladus has all the ingredients, or most of what is needed, for life. That makes it a very astrobiologically interesting object to study. Europa is one of the largest moons of Jupiter, and it is believed that Europa has a subsurface ocean tens to hundreds of kilometers thick. And so, this ocean may be one of the best places to search for life in the solar system. There have been 3 space missions that have provided evidence for Europa harboring liquid water. The first one is Voyager in the late 70s. The second one is the Galileo mission in the late 1980s. And most recently, Hubble, which detected plume-like emission from hydrogen and oxygen, which is closely related to the existence of water beneath its surface. These plumes may be directly ejected through cracks in the surface of the moon, and therefore, what is being seen in water vapor plumes is the actual ocean water from the subsurface of the moon as these plume particles are ejected to space. Solar radiation is going to excite these water particles, creating vibrational modes. Now, these vibrational modes are signatures that can be detected at infrared wavelengths by the Keck Observatory. Europa was observed on 17 days. What was found is that the majority of observations had no presence of water. However, on one of those dates, water was detected. H2O was detected. In the past, Hubble provided indirect measurements of water by detecting hydrogen and oxygen. But now, water has been directly detected for the first time. Both the Webb telescope and the Europa Clipper mission will give a much more detailed picture of the surface of Europa. Its cracks and crevices, detailed pictures of the water vapor, as well as other molecules that may also be emanating from the subsurface of Europa. So both of these missions will give a great picture of whether Europa is truly habitable. Titan is a moon of Saturn. It's the second largest moon in the solar system, and it is about 2 times larger than Earth's moon and actually bigger than the planet Mercury. And Titan is also interesting. It's the only moon in the solar system with an atmosphere. It's surrounded by sort of an envelope of gaseous nitrogen, just like Earth's atmosphere. Titan was first discovered by telescope observation back in the mid-1600s. The first spacecraft observations were made of Titan during flybys through the outer solar system. That was in the late 70s and in the 80s. But Titan was explored in depth with the Cassini-Huygens mission. The Huygens probe was dropped into the atmosphere of Titan, and it made measurements of chemistry and took images as it fell to the surface. That was back in 2005. And since then, the Cassini orbiter made over 100 close flybys of Titan. Cassini, in its design with the different instruments, was purposely equipped with instruments that could go into longer wavelengths, into the infrared, to really understand the moon. It was possible to basically peel back the layers of Titan to really see what was below. And it was remarkable, very Earth-like. The landscape is similar to Earth's in many, many ways, but with a little bit of a twist. So on Titan, dunes can be found, lakes, river channels. The atmosphere is very dense, and clouds, smog, and even rain are present. Winds were observed in seasons as well. And one really important thing that was seen was liquids pooling in the polar regions on the surface, a lot of it. But because Titan is so cold, those features are all made of very exotic materials compared to what is found on Earth. So the lakes and the rain are made of liquid methane. The crust that forms the surface of Titan is actually water ice, but it's so cold that it's as hard as rock. And in the atmosphere, there is organic chemistry that forms large organic molecules and particulates. They fall down to the surface and then behave like dust or like sand does. So there is a strong desire to return to really understand the complex organic environment of that surface and what it means for either past life or maybe future life. Dragonfly is a mission that was just selected by NASA to fly to Titan and arrive in the mid-2030s. Dragonfly is going to make a whole bunch of measurements to help better understand the environment on Titan and its potential for habitability. Measurements of the atmosphere will be taken, including things like pressure, temperature, winds. The surface will be probed to try to understand what materials the surface is made out of. Drilling into the surface will also be done to look for the types of organic molecules that are present, and to try to see if there are any examples of compounds that mimic the types of building blocks known to be essential for life on Earth. It is still not fully known how life started on Earth. The exact chemical environment of early Earth before life began is also uncertain. So, with Titan, there is this really unique opportunity. There are times in Titan's past where there could have been liquid water on the surface. Impact craters can generate impact melt, and there's a potential for possible cryovolcanism to erupt some liquid water onto the surface. And there is known to be rich organic chemistry going on in the atmosphere. That chemistry is depositing onto the surface. If there were times when those organics and the liquid water environments were mixing, then some really interesting chemistry may have been taking place. And when those processes operate for hundreds of millions of years, how far can they get down that path of chemical complexity? Can reactions and molecules be seen that start to resemble what are considered essential elements of biochemistry on Earth? Looking forward, rather than just looking back, Titan becomes a kind of chemical laboratory for the prebiotic Earth. There is also the question of what's going to happen when the Sun evolves and warms up, and the habitable zone actually moves out to where Titan is, and it will. All the organics are there. A source of energy will exist. All that will be needed is to melt the frozen water, and there will be a pool of organics just embedded in liquid. Titan might actually have a chance at that point to harbor life. When thinking about ocean worlds, it's useful to compare them to what is known about Earth. In total proportion, Earth is about 0.1% water. An ocean world is a body that has, in proportion, about 10 times more water than Earth does. And when considering the TRAPPIST planets, those planets have about 50 times more water in proportion to what Earth has. Ocean worlds do appear to be common in the galaxy. As far back as the early 2000s, astronomers, some of them still working at NASA Goddard, suggested that ocean worlds would be found orbiting low-mass stars. Recently, about 52 exoplanets were studied, and these are low-mass exoplanets. What was found is that of these 52 planets, 1 out of every 4 may be an ocean planet. And when it comes to these ocean planets, over half of them may be ice-covered ocean worlds. So Enceladus and Europa may serve as small-scale analogs of these planets. There are a number of different ways to search for life on planets around other stars. But the key method is the study of the atmospheres. Signs of life, biosignatures, can be searched for. These include things like oxygen, water vapor, carbon dioxide. Even more unusual biosignatures, such as chlorofluorocarbons or other compounds that are only produced by intelligent life, could be detected. By looking for these key constituents of planetary atmospheres that signal life, it becomes possible to discover life forms on other planets that could never be visited within a human lifetime. This is very analogous to how the atmospheres of moons and planets in the solar system are studied, and really makes the connection between studying the plumes of Europa and the atmospheres of planets around other stars. What would be valuable to see is a broader definition of a habitable zone. It's important not to think too narrowly about liquid water only being on the surface, but to broaden the scope and truly embrace other worlds that might seem too far from their host star and frozen out, when in fact they may not be frozen at all. At great depths, they may harbor a warm, hydrothermal-driven, liquid water environment. So, what have we learned? The ingredients for life, water, chemistry, and energy, may be hiding in some of the most unexpected corners of our solar system. Beneath icy crusts, inside distant moons, and in oceans far beyond Earth, the universe is filled with possibilities. From Enceladus and Europa to Titan and beyond, the search for life continues, not just on planets, but in the hidden oceans of worlds once thought barren. Thanks for watching with us here at Wormhole to Cosmos. If you enjoyed this journey, Give us a thumbs up, subscribe, and stay tuned. We've got even more incredible videos coming your way. Remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.